Okay, so since we have finished monetary rule, a final component of three-equation model, we can summarize. So monetary rule is represented by the following equation, where pi t is equal to minus 1 over alpha beta times yt minus ye. For Phillips curve, we have level of inflation in period t to be equal to expected rate of inflation in the respective period plus alpha times output gap. And for IS curve, we assume output to be equal to aggregate demand minus AR. So here we have to introduce minor adjustment and assume 1 period lag for IS curve. So any change in interest rate in period t will affect economy only in the next period or t plus 1. I believe it makes sense, because no one reacts to changes in interest rate immediately. So it just adds some explanatory power to this model. So once we have three-equation model, we can proceed to analyzing different types of shocks, which is relevant to your coursework. So let us start with inflationary shock. Okay, so how it's... Okay, shall be fine. So under inflationary shock, we have to depict what's gonna happen to the real and financial sector depending on the policy response. Because previously when we discussed Phillips curve, we assumed that there is no intervention of the central authorities, and the prediction was pretty pessimistic. So we expect never-ending increase in inflation if there is no policy intervention. And now we assume there is policy intervention. Okay, so what we do is we start with economy in equilibrium. Probably, as usual, you always start with equilibrium. So we assume that level of output is equal to potential output, and this corresponds to the interest rate Rs. Okay, output. So we assume that initially inflation is equal to target level of inflation or pi tau, and this happens on the intercept of monetary rule and Phillips curve. Yes. Okay, so please keep in mind that in period 0, expected rate of inflation is equal to pi tau, simply because here at zero output gap, inflation is equal to pi tau, which automatically implies that expected rate of inflation was equal to pi tau. Also, it implies that the actual rate of inflation in period -1 was also equal to pi tau. Okay, and I forgot to add IS curve here. So let's denote this initial point as A. And here, as I said before, we analyze inflationary shock. Inflationary shock means, by definition, rapid increase in inflation rate in the economy, which is not corresponded by any change in the value of real output. So basically, we just, move along this value of output from point A to point B. And actually, point B is the rate of inflation in period 0. Actual rate of inflation. So let's summarize. In period 0, we move from point A to point B. We end up period 0 with the rate of inflation equal to pi 0. So now, actually, we have central bank, a rational player, who definitely can say that, which can definitely say that point B is not an optimal loss minimization point because it's not located on the monetary rule curve. So in this case, central bank tries to predict what will happen in period 1. And basically, if we end up period 0 with inflation equal to pi 0, then it automatically becomes expected rate of inflation in period 1. Yes, so again, at this point we have no output gap and the rate of inflation is equal to pi 0. So based on this, we can conclude that for this Phillips curve, PC1, the expected rate of inflation is equal to inflation in period 0. And since, pi 0 is located above pi tau, like value of pi 0 is bigger than the value of pi tau, this curve is located above the original Phillips curve. Because, looking at the formula of Phillips curve, it's easy to prove that expected rate of inflation, like value of expected rate of inflation, affects the value of intercept. So if it increases, the function basically shifts up. Curve basically shifts up. Okay, fine. So central bank predicts PC1, here we have it, and central bank knows that in the next period, C will be the optimal point for the central bank, simply because it's gonna be on the intercept of monetary rule and Phillips curve in period 1. So in order to have C, in order to be located at point C, central bank has to establish, corresponding value of the interest rate. Here we are. So this is R0. So to summarize, that's it for 0 period. We end up with higher level of inflation, pi 0, and we end up with R0 charged by the central bank in period 0 for the sake of, being located at this point in period 1. So that's it for period 0. Let's analyze what's going to happen in period 1. In period 1, we actually move from B to C and from A to C. So now it's not hypothetical predicted Phillips curve, it's just Phillips curve. So finally R0 came to play, so it affected output, and obviously increase in interest rate affected output negatively. So here we have Y1, the value of output in period 1. So we end up period 1 with level of inflation equal to pi 1. Here we have it. Level of output equal to Y1. And now let's see what central bank's gonna do. So central bank notices that in the first period, rate of inflation is actually lower than in 0 period. So pi 1 is below pi 0, which means that expected rate of inflation in period 2 will be smaller than expected rate of inflation in period 1. Because this value is equivalent to this value is equivalent to this value because of our assumption of adaptive inflationary expectations. So since expected rate of inflation is lower in period 2 in comparison to period 1, in period 2, Phillips curve will be located below Phillips curve in period 1. So this is what we have. PC2. So again, at this point, this is just a prediction, but nevertheless. So central bank knows that in order to be located at point D, which is on the intercept of new Phillips curve and monetary rule, it has to charge interest rate equal to R1. So R1 will affect output only in the second period, but nevertheless, we end up period with R1. So now we are done definitely. Finally, let's analyze what happens in the second period. In second period, we actually move from C to D. Oh, by the way, I forgot to mention that in the first period, here we move from A to C. Oh no, I did. Okay, good. Good for you. So in second period, economy actually moves from C to D. Level of output is equal to Y2. Level of inflation here is equal to pi 2. And yeah, so here, since we have decrease in the rate of inflation in this period, because pi 1 is lower, exhibits lower value than pi 1, we know that in the third period, the same stuff will happen. So Phillips curve will shift down and down and down until actually we reach point A. So point A is simultaneously point Z, like initial point when we started is the point at which economy should end up at the same time. So economy will slowly move to point Z from period 2 and onwards. Okay, ta-da. So this is the end with this analysis. One more thing, we have to discuss the idea, behind response functions. Okay, so we have three variables of interest, which are real interest rate, output, and yeah, now it's gonna be visible, and the rate of inflation. So we analyze how they depend on time. Yeah, let's have period 0 because all the stuff started in period 0. Period 1. Okay, and maybe we shall start with inflation. So inflation was equal to pi tau before period 0. And then in period 0, it suddenly decreased to pi 0 because of inflationary shock. So looking at this graph, you can actually follow this idea. So inflation rapidly increased in period 0 from A to B, and then it slowly decreased until it reached its initial value. So now, okay, so here we depict this slow decrease. Yeah. So, this is just to show what happens with inflation on this graph. So as I said, there is rapid increase in period 0, and then there is smooth decrease. So exactly the same you can see on this graph. When it comes to R, so we started with RS, just some initial value of the interest rate. I don't really remember how it's denoted in your textbook, but it's just initial level of the interest rate. As you can see on this graph, it increased sharply from A to C, then it was decreasing from C to D, and so on and so forth. So rapid increase in period 0 was followed by, maybe we'll do it in this way, by smooth decrease until interest rate actually reached its initial level. When it comes to output, initially output was equal to potential output. I would like to say before period 0, but actually before period 1. Because take a look, in period 0, output was not affected. Actually, output was affected only in period 1, when interest rate charged by the central bank in period 0 came to play, let's say. So here, In output, you can see just the opposite trend. So we have rapid and dramatic decrease in the value of output, and then it was slowly increasing until it reached its original value. So it decreased till y1, and then it actually increased until it reached its original value. So yeah, this is the idea behind the response analysis. So here it's done, based on purely theoretical analysis. You will have to do it based on vector autoregression model, but please do not be that frightened. We're gonna discuss everything. You will have a tutorial once we finish all the types of shocks. So that's it, and thank you for your attention.